The number of firearm-related deaths in the United States are shown in the table at right for various years, and this comes from the Centers for Disease Control and Prevention. Let D be the number of firearm-related deaths in thousands, T years after 1990. A reasonable model for this situation is D equals negative 1.7 T plus 45. So our goal here is to graph the model by hand and then use the graph to predict when the number of firearm-related deaths would reach 20,000. So let's just take a little look at the information that's given in our table here. Notice that we've got information about years and we have the information about the number of firearm-related deaths in thousands. And so thinking back to what we know about dependent and independent variables, remember the independent variable comes first and the dependent variable comes second. So here the information about the year is the independent variable, and that's the information about year. And notice how they had us talking about the years after 1990. So that's my T information here. And then the the D part, the D represents the number of firearm related deaths in thousands. So there's my D information. That's for the dependent variable. So this is just to kind of familiarize ourselves with the information that's given to us and how we should set up our graph. So some of the work for the graph has already been done. Notice that the T is here along my horizontal axis because that's where we find information about the independent variable. And that T represents years since 1990. That just came directly from the problem, the information that was given to us. And then our dependent variable, remember we said was D, and that had to do with the number of firearm related deaths in thousands. So we've got our axes scaled or we've got them labeled, but we still need to scale our axes. So let's think about what might be a good scale for this. Let's start with the years. So the years that we need to cover, we're going to be starting in 1990. So that's going to be our starting point. And we know that we need to go out to 2000 because that's how far my table goes out. But notice that in 2000, the number of firearm related deaths would be 28,000. And we need to do a prediction for when the number is going to be even lower than that when it's out to 20,000. We can see that the values are getting lower as time goes by. And so what we want to do here is we want to be sure that my graph goes well beyond 2000 because we're not sure how far past 2000 it's going to take for the number of firearm related deaths to get down to this 20,000 point. So on my graph, even though I have about 15 lines going across, I'm not sure if 15 years since 1990, which would be 2005, I'm not sure that's going to be far enough. So rather than scaling by ones, I'm going to go ahead and scale by twos. So I'm going to have every line on my horizontal axis represent two. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm going to do one more, 22, 24. So hopefully that will be far enough out to see where the number of deaths gets down to this 20,000 mark. On my vertical axis, notice that we're going to have to account for a y-intercept of 0, 45. And so we need to be sure that we go up to at least 45. Well, certainly scaling by ones isn't going to be good enough, or twos. I certainly don't have 20 here. So usually if ones or twos don't work, fives is the next scale mark that sort of makes sense. Fives are nice and easy to count by. So let's scale our vertical axis by fives. So again, I'm going to scale by fives, so I'm just going to label every other line. So here's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So that should get me up high enough that I need to go. So now we need to figure out how we're going to graph this thing. The y-intercept is straightforward enough. It's at 0, 45, so we can certainly go ahead and put that 0, 45 mark right there. The slope is a little bit dicey though, so let's think about how we might be able to deal with this slope. So the slope, remember we use m for the slope. The slope is negative 1.7. And I'm thinking, well, how can I use that to think of the idea of the rise over the run? I said, well, I'm not just exactly sure. We've seen before when we have a number that's not a fraction that we can put it over 1. And that still works in this situation, but notice this looks really weird to have a decimal within a fraction. So what our goal is going to be is to get rid of this decimal point. What we're going to do is we're going to multiply this fraction. Because I need to move this decimal point one place, I can do that by multiplying by 10. But if I multiply the numerator by 10, I have to multiply the denominator by 10 as well. So what that means is now my slope is going to be, well, negative 1.7 times 10 would give me negative 17. And in the denominator, 1 times 10 is going to give me 10. And you could verify this on your calculator. If you took negative 17 and divided it by 10, you would see, sure enough, you would end up with negative 1.7. So these two are equivalent. So now I have an idea of how to work with my rise and my run, rise over run. Now there's one other thing we have to be careful of. Remember when we talk about the rise and the run, so the rise is how we move in the vertical direction, the run is how we move in the horizontal direction. If I come over here to my y-intercept, which we said was 0, 45, I want to go down 17, right? Because remember it was a negative rise down, so that means it has us going in the down direction. But going down 17, I'm not going to count lines. I'm not going to count 17 lines. You can see I don't even have 17 lines to count. I need to go down 17 units. I need to go down 17 from this starting point of 45. So how far does that mean that I should go down? Well, if I take 45 and I subtract 17 and do the subtraction, well, I need to borrow here. And so that would give us 8 and 2. So going down, I need to go down to 28, which would put me right about here. So notice, remember each line of these is 5. There's 5, 10, 15, and then another 2 has me at 17. So that puts me down 17. So we have to be sure we're not counting lines, that we're actually taking into account the scale. Now we need to run 10. Running 10 is going to be a little bit easier here because going from 0, where I'm at right now on the horizontal, over to 10. Remember, here's 4, here's 8, here's 12. So 10 is this middle line between 8 and 12. So from here, I'm going to go over to 10. And that's going to give me another point on this line because I've gone down 17 and I've gone over 10. And we could do that again. We could go down 17 and over 10 as well. Where is that going to take me when I go down 17 from 28? Well, I'm just going to subtract again. That's going to take me down to 11. So from here, I'm going to go down another 17. That's going to take me down to 11, down 17, and then again over 10, and that's going to take me over here to 20. So down 17 and over 10. Okay. So you can see how we have to really pay close attention when we have a different scale about how we're going to use our slope. We're almost done now. We can grab our straight edge and we can create the graph of our model. So my straight edge is hiding up here. Let's bring her down. And I'm going to line it up right there with that top. Whoop, didn't want me to line it up quite yet. I'll line it up right there. And I'm going to pivot it around to go through those 2 points that I found. And I can see that it's going to line up pretty nicely for me there. I grab my pencil. And I'm going to draw my line. And now I'm going to get rid of my straight edge and see what we've got here. Here's my graph of my model. I'm going to put my arrow on here to say this thing's going to keep going. When will the number of firearm related deaths reach 20,000? Well, let's see where that is on my graph. Here is where we measure the number of deaths in thousands. So here's the 20,000 mark. So let's see where that hits the line, the graph of the model. I'm going to come across here. Seems to hit it kind of nicely right there. I'm going to bring it down and see where that hits on my d-axis, my years since 1990. And this line right there would represent 14 right there, halfway between 12 and 16. So that's my 14 mark. 14 years since 1990 would be the year 2004. So we would think that our prediction would be in 2004 the deaths are going to reach 20,000 deaths that are related to firearms. So you can see there's a number of things you have to really be careful of when you're creating these graphs of story problems where the numbers aren't just nice and tidy for us. But we do have all the tools that we need to do this. We just need to take it one step at a time and we'll be able to do all the work that we need to do.